Yes. Thank you all for joining us live today for today's Open Talks. So, Open Talks is a new initiative from batteryline.com where we highlight the proven capabilities of our members in scaling up battery production or even recycling. So, today we are joined by Alexandre Coulio from Mecasonic, who will discuss on innovating battery recycling solutions with ultrasonic solutions. At the end of the presentation, audience who have joined today can directly ask Alexandre the questions related to ultrasonic solutions in battery recycling or manufacturing. So now I request Alexandre to introduce himself to the audience and start with the presentation.
So hello everyone. I'm Alexandre Coulot. I'm working for Mecasonic. I'm a area manager and also specialist in battery process. We joined battery lines to help the industry scale up uh, for this ongoing project, worldwide project of EVs. And today we will have a special look on the aftermath because we have to produce, but we have also to think about what's happened next. Maybe we can start with the presentation.
Yeah.
So, to explain a little bit about what we want to do in recycling, which is the core question of today, I will take a little bit some space to understand and explain what is ultrasonic welding. So, ultrasonic welding was, let's say, invented. It is a process we are using today in the 40s. It was mostly patented in the 60s in the US for plastic welding mostly. We move for different steps. The principal process is using piezoelectric principle. You have different variation in the industry today, but it's mostly the same kind of process used by every supplier on the market. So the electrical energy will be transformed using these principles from electricity to a mechanical vibration. So what is important in this phase is to adjust a current frequency. The frequency means how many movement you will have during a second. So for example, if we speak about 20 kilohertz, it means that during 1 second, you will have 25,000 movement of the horn. You can see on the presentation, this is an acoustic stack, a standard one. You have the main components of the acoustic set, the converters, which use this principle of piezoelectric. So inside you have ceramics. Under electricity property, you will have an extension. So the extension will be transferred to a part called a booster. So his name, it's very easy to understand. It's to increase the signal given by the converters and the generators. And this movement will be also transferred to the horn or the sonotrods, will give some extension. So we measure this extension, what we call an amplitude in microns. Most of the horns in the market are between, let's say, 40 to maximum 200 microns. For plastic welding, it's very important to know these amplitudes because it will be related to the plastic we weld, because most of the ultrasonics used in the market are for welding. Why using ultrasonics? When you understand the property, what is important to know is in comparison with every other process for assembly, it is the fastest one. We speak about seconds. I see some specific application, we speak about milliseconds. So it's very fast in comparison with other possible technology you can find on the market. But it's, I think, the best one in meaning of speed, but also in meaning of investment, because the speed you gain with this technology is helped by the relatively small cost needed for investment in this particular technology. It's also help every user for this kind of technology to have removed any added material. If you speak about assembly, before you had the process with screw, so you have to pay the screw, and you have also to design a specific parts. If you design with a knowledge of using ultrasonics, you don't need any added material. You don't need screw, you don't need glue, don't need anything else. So it's very easy to calculate the cost and return of investment you put using this technology. What is very important, and it's why it's important to understand why we are using ultrasonics, is also its versatility. Technically, the same kind of material can be used in different process. We speak today about electrical vehicles, so it can be used in every steps of all process for production. And later on, we will see that we can also use for recycling, which is the main point of today's webinar. What is also important with ultrasonics is repeatability. So current process, okay, it's fast, but we have to be precise. We have to be homogeneous, because what is important, if you produce 1 million, 1 billion cells for battery cars, is to have the same for every car. We don't, I see yesterday a very interesting article that some producer of batteries want 1 scrap per billion cells produced, which is in industry very, very tough to reach. But I think ultrasonics will be maybe the only one able to reach this kind of request. How we use today ultrasonics in battery process? So you have 3 different, let's say, family. You have first plastic welding. I want to be mostly focused on battery production. So inside battery, you have different level, mostly the cell itself, with use variety of plastics. So you can sell the push cells, you can rivet the carters, you can cut the foils between anode and cathode. I will let you take some other view on battery lines that explains the complete process, but because of limited time of today, I will be mostly focused on ultrasonics. So for plastic welding, you have many steps that can be used, ultrasonics. You have also metal welding. We use exactly the same principle of functioning. You have the same acoustic set. It's a different presentation, a different use, but the basic theoretical property is exactly the same. So you can use metal welding for tabs, for bus bars, cables, inserts. I also made a focus on solid state batteries on battery lines, which is, I think, the next level for batteries. I think the liquid states, it's something not dying, because we will have many models, but I think the next step in industry for 25 to 2030 would be solid states battery. And solid states with metal can be very effectively produced using ultrasonics. What is important also, and I think most of the companies understand now, is, okay, you produce, okay, I use my ultrasonics. Maybe I have also to think about what's happened next, recycling. So ultrasonics, with the same property, with the same kind of material, you just have to adapt slightly the tool, but mechanically the generator can be exactly the same. You can use ultrasonics for recycling. What is very interesting is you keep the same advantages for production, for plastic, for metal, for recycling, mainly the speed and the repeatability. So it's a very interesting technology, and I think more than interesting, it's very efficient. When you speak about engineer, they understand why. When you speak about purchasing manager, they understand why. When you speak about user, they understand why, because different advantages fulfill the request for every steps in the process. So I think what you have to understand is, if you think about how I can use ultrasonics and where I can use ultrasonics, everywhere. We speak about batteries, but in daily life, textile, cars, food, everywhere ultrasonics is used. And we have to scale up and help the industry use this technology also in battery production, but also in battery recycling. So this is a core today of this presentation. I will take a little bit more time. In this presentation, you have mostly the process mostly used for recycling. So what is very important to understand before going deep in the detail how we use ultrasonics for this specific step, what is very important is, okay, I collect my battery. The car has been renewed. I have my battery. I disassemble the main components, but first steps, I need to remove any potential energy. I don't speak about these steps in the presentation because I wanted to also show you that the process is much more complex than just use ultrasonics. But now on, I think for the past 10 years, many companies made patents about how to discharge batteries. I have a good contact with a company in Central East Europe. They discharge the battery before disassembly and gain some energy they can reuse for the recycling process. So they really think about sustainability, which means that from the A point to the final point, you think about every steps and how to use every components, every aspect of your material for your own business. Because I hope it will be charity program, but most of the time it's money at the end. So it's very important to understand that every space, every part of the process can be useful and making money for this complete process. When it's discharged, when you recover this energy, now you have physically to dismantle every part on your battery cells. This is a big difficulty today because when I discuss with actors on the market for recycling, the main difficulties is every brand, every model, every cars basically have kind of different cells. If you have a Tesla, if you have a Japanese car, if you have a European car, Volkswagen, Skoda, every brand have its own way, and most of them are covered with NDA, with patent. So most of the time they don't know what they are looking for. Good things is basically ultrasonics can be used no matter what you have. You will have to adapt slightly the tool to be connected to what you have physically, if it's a cell, if it's a push battery, if you are not only involved in anode or cathode. It's no matter where the ultrasonic will be useful in every kind of material. You just slightly to adapt your tool to the brand or to the material you will work with. So when you have this cell, when you have this battery, you have physically to dismantle. So most of the time, now on, if you don't use ultrasonics, I saw many times manually removed, sometimes just put to a machine to destroy everything and try to recover different process to recover some materials. Currently, if you do this kind of process, you recover 20 to 30% of the original materials that can be reused. The rest 70% it's used for different other process. For example, if you want to make a plastic bags or something like this. But only 20 to 30% of the original product is recovered. If you think about ultrasonics, you use from the beginning a vibration property, which means that when you touch a part, you have a vibration, and it's very important to contact the parts you want to weld, increase the temperatures, melt it, and so on. If you know a little bit about ultrasonics, sometimes I have some application when you have two steps of welding, which I said it's very difficult because when you have a vibration very close to another welding, most of the time you disassemble the first welding. The connection in vibration are so strong and so fast that even at distance you dismantle everything. So you have a part, you want to weld something, it's welded, okay, I want to put another part on top of it, okay, I put my welding and everything in disassemble like a puzzle. It's very important to know these facts because you think, okay, I want to disassemble in my recycling process, so maybe I can use ultrasonics. And it's exactly the same property used for assembly that you can use for disassemble, which means you touch one part of your plastic or one part of your metal, and the vibration will disconnect if you have two materials connected. In this presentation, you have a focus on, for example, anode and cathode. You have this black powder around this cathode and anode, which collects the electricity for the battery life. If you put some ultrasonics vibration in this specific step, you will be able to easily separate cathode and anode from this black matter. And we speak about less than 1 second. I also discuss with companies in recycling process. Currently, if you don't use ultrasonics, you use chemical process to do exactly the same goal, and it takes 6 to 90 minutes to separate cathode or anode, which is a metallic foils or copper or aluminum, most of the case. It takes 6 to 90 minutes to be able to recover, and you have 70% purity of the metallic foil you will recover. If you switch to ultrasonics, the same process will take less than 10 seconds, and you will be able to recover 98 to 99.9% of your material, which means that basically you can make the process, recover the parts, re-put the same in the battery process for making it with no waste, no loss in any case. You will have also the possibility to recover other parts of your battery, but for mining, when you think about every kind of quantity of copper, of aluminum, zinc, cobalt, lithium you need to make a new level of batteries worldwide, and you said, okay, I already produce, the numbers are not real, but it's supposed to be 16 to 20 million electricals are currently in use worldwide for the past 5 years. It's not much in comparison to thermic cars, but you already have 20 million cars available on the market. So if you have to recycle it, you can make maybe 10 million more with the same quantity of cars, which is very important. Today, only 30% of what we produce in meaning of capacity are existing. And on this 30%, I think less than 1 or maybe 2% are using ultrasonics. So the only way to scale up and match the goal of every producer of cars worldwide, which means that I produce a car, I want to recover 99% in meaning of recycling, but also in meaning of material. I need to recover my material because I paid one time and that's it. I don't have to pay every time I need to build a car, new kind of batch of materials to reproduce a car. So if I have a car, I wait 5 to 10 years to be used. I take the car, I disassemble it, I recycle it, everything. I recover 90% of my material. I just have to add the 10% that we need at the end. So this kind of process, it's very important to understand that if we want to reach the goal of sustainability for every companies, when I heard Volkswagen, Toyota, Tesla, yeah, we want as a goal, but we also need the tool to match the requirement. And I think only ultrasonics can be used for reaching this goal. I just read this morning an article. Now, for example, during process of the battery, they already think to have components easily able to be disassembled. But easily means you need to have a specific process. If you think about designing from the beginning, yeah, I want to make my battery, my cell, with a specific design to be able to ultrasonically be recovered later, you win the job. You don't have to do anything else. So it's very important to understand that many actors on the market, and it's our responsibility, are aware of the technology in the production level, because yeah, ultrasonics in automotive industry since the 80s are mostly used everywhere for every kind of brand at every level. But now they have also to understand that it's also possible to use the same property, sometimes the same material, to recover everything they need. So it's important to give the information that ultrasonics is very easy to reach, because yeah, a machine, even if you have a recycling process already existing and you just want to speed up existing line, yeah, you put an ultrasonics machine, can be easily integrated. We sell standard equipment that can be integrated very easily, and it took, let's say, 1 week, allez, maybe 4 weeks to be produced, 1 week to be installed. In 5 weeks, you reduce your speed of recycling by 100, 1,000 times. You don't have to add chemicals, because most of the process today are using chemicals. So you don't need to have a specific line with a lot of protection for operators, for the environment, and so on. You don't need anything else. So it's very important to make understand the companies that yeah, ultrasonic can be easily used. It's cost effective, it's efficient, it's fast. What do they need more? I think what is important for them sometimes it's only money. Unfortunately, even if we are companies, we have to be there to make money and to improve, to make sometimes more money, but most of the time to be more efficient. And efficiency, if it's the main goal of many CEO, of purchasing manager, ultrasonics is your ultimate technology. You have everything you need in this kind of possibilities to do everything you need. So if you understand the physical property of ultrasonics, if you understand that, yeah, I understand a little bit ultrasonics, I have already machines to produce some components, some plastic parts, or maybe I can maybe use the same machine to do another process that will be able to give me raw materials I can reuse in my line. It's a very important thing to understand, and I'm glad today that even my competitors, my colleagues, is also explaining that yeah, what is very important is speed, okay, gaining money, okay, but it's also to understand that you are very efficient in recovering the material. You avoid to waste 90, 70, 80% of what you put in the original line. You can recover 90% of what you put in the line, and you can remake new cars. So I think it's very important to understand, and I think it's one of the best advantages we have in the, let's say, North America market, European market, in comparison with Chinese brands that are not ready for this level. In Europe, we are maybe too fast in the process. We think about sustainability before selling cars. We have to find a balance in between. What is important is to say, okay, we scale up, but we have to scale up in ABC plan. You have to make first your cars, but if you think about, yeah, I want to reuse, recycle, you already win. Because if the car, because I have no deep knowledge about current lifetime of Chinese components in the market. Many people are afraid or questioning the abilities for a battery to be able to have 5-10 years lifetime. What I'm sure is every actors I discuss with in the market for recycling process, when they find out Chinese equipment, they are very, very poor in meaning of possibilities and easily possibilities to be adapted and recycled. I think when they said, I had an example with Volkswagen, and they said they think about it. They already know that we need to make something that can be easily recycled. So they even give patent to companies to be able to be easily recycled. So this is an advantage that we have to put in front of our discussion and help the industries, the companies to scale up, but also explain them that it's for their own benefit. We are a consumer. We are an actor on the market, but we are also a human. We need to be able to say, okay, maybe in 20 years we will have no more copper. What we will do? It was the same idea with petrol. 20 years ago, it was one day we will have no more. Maybe think is the same for every raw material we put inside those batteries. So ultrasonics is my job. I work for Mecasonic for many years now, but I think recycling is our duty. It's very important to understand that the point behind everything we are involved is to help every actors on the market, the suppliers, the users, the final customer, making things better. So I hope you enjoy this presentation, and I think we will be ready for some question.
Thank you, Alexandre, for this very insightful presentation on ultrasonics, and also you did a great job by first educating what is ultrasonic to our audience, then telling how ultrasonic can be used in battery manufacturing and recycling. So that was very helpful. And I see many of your colleagues have also joined, Vincent and Sarah. Thanks for joining us live today. And we have one more viewer who is Richard Good from Orkla. Thank you for joining us today. Feel free to ask questions in the chat box, so we can go through it now. And, so Alexander, we have a question. So how scalable are ultrasonic recycling solutions as of today? As you mentioned that we can disassemble parts of batteries, but is it done in a small batch or can we do it in a mass scale?
I think you can intervene in every scale. We have some companies with only one machine that make maybe 100 tons per year of recycled material. and it's the same material that can be used for a complete line of production when you can use 16, 20, 100 machines. Um, Unfortunately, I have no um, current process production with this kind of scale, but I have some discussion for sure with some companies that want to scale up from 100 tons to 500 tons, from 1,000 tons to 100,000 tons. The goal in Europe is to be able to scale up battery material, so including the plastic, including the metals, including everything inside, to be in capacity in 2030 of 200,000 cars per year, only in Europe. This will be, I think, for 80% of the market between three main companies. One is already in a field of production. Two are in a, let's say, final line of production. So it's very easy to integrate, very easy to scale up. As I mentioned earlier, in 5 weeks you can move from a current process of recycling without using ultrasonics to using ultrasonics. So it's fast, it's very cost effective. We speak about between 30,000 to 45,000 euros for one unit. So I think if you compare how many raw material, if you are just a recycling companies that just do recycling, if you collect 100 tons of copper, of aluminium per year in one machine, you can just make the calculation. But I think it's easily reimburse every investment you make for this kind of material. And as I mentioned, you have the same machine and you can use for recycling and you can use for producing plastic parts. So scaling it up, it's not an issue at the moment.
We have a question from Richard from Orkla, and he's
Mhm.
asking, can this technology be used in developing countries that generally have lower level of skills and smaller markets for recycling?
I think is maybe the main target we have, because unfortunately, many recycling process are not done where we use the material. Africa, India, South America are leading in quantity of material recycled. In Europe, in North America, in Asia, China, and Japan mostly, uh, they recycle heavy material, but lots of small material are recycled in Philippines, in Vietnam, in Bangladesh. So ultrasonics, if you have electrical plug and a pneumatical compressor, you can do everywhere. So basically, me personally, I'm area manager for many countries. I have all South America, I have India, and even if they don't have the same level of infrastructure and the same level of selling electrical car, it's can be easily done in Central Africa that can be done in Norway. It's exactly the same machine, exactly the same process. And I think many I met a company on a fair based in Egypt, and is making only raw material for batteries. It doesn't involve in any very complicated process. It's basic raw material. And he said, okay, I will buy one machine, and I will also provide recycled. So I sell to my customer material they used. They send back 20, 30% of the material for recycling. They recycle with the same machine and send it back. And it's a vicious circle. So even in non-developed country, you can easily scale up or create. We speak a lot about scale up because I have mostly knowledge in Europe and North America, which is, yeah, sustainability, production of cars. But scale up is one very important process, because 80% will go through this market. But we have also to create sometimes. and creation of this process everywhere in the world, it's not an issue. You just need electrical plug and pneumatical compressor.
I hope that answered your question, Richard. And if you have more questions, please post it here. Uh, Actually, I had a question, Alexander. So you mentioned that we can skip the chemical parts in recycling by using ultrasonic. So what happens in the conventional method is that they first shred the batteries and they recover black mass, and that black mass goes into chemicals for separating the nickel or cobalt or lithium in that black mass. So, can you explain more, like how ultrasonic can separate these chemicals?
I will just take back if it's possible to, yeah,
Yeah,
just if it's able to see the production. So you see here in the batch, you have the separation between anode and cathode using ultrasonics, and you go to a bath. Okay, this mechanical process, what you need to separate anode and cathode between metallic foil and the black mass, it's to separate, but also to collect. Most of the mechanical process or existing process use chemical to separate anode, cathode, and black mass, and also separate elements of the black mass inside some bath. As I mentioned, this is a process that can take like 90 minutes. We speak about very heavy chemicals. It's not like something you can easily find on the market. It's very complicated acids that it's required level, very high level of safety for the plant and so on. If you use ultrasonics, technically, you can do exactly the same process using demineralized water. So you skip a very heavy chemical process to only mechanical process using ultrasonic vibration. So I didn't insist because also most of the companies want to recover some material in the black mass. So they need chemical process because in a ultrasonic property, you will be able to separate black mass to anode and cathode. But you can also use ultrasonics to separate some components in your black mass. But most of the time, to be much more efficient, you still need some chemicals to be able to separate and compact every element separately in a bath. You have different layers in a bath, and only chemicals can be used to separate these elements. But most of the time, the black mass, it's not reused, unfortunately. I think ultrasonics can also be able to be used to help companies remove completely chemicals. But instead of removing complete, I think the first step is at least to use much more. I'm not a magician. I cannot say, yeah, you come, okay, you use ultrasonics and everything disappear. I hope it will be possible, but reality, it's much more complicated. And at least if we reduce in 95% all chemical in the process, I think it will be a good win.
Thank you, Alexander, for that explanation. So we have one more question. What are the environmental impacts of adopting ultrasonic solutions in battery recycling, particularly in terms of energy consumption and emissions?
So it's true that ultrasonics use electricity. For this specific process you can see on the presentation, we will use, let's say, 2000 watts for 10 seconds. Again, I cannot see a process that doesn't use energy, but we replace something existing. I think if you put some chemicals for 6 to 90 minutes at temperatures control, because you have to put the chemicals at 60, 50 degrees, it needs energy, and it's need energy for 90 minutes. I don't know the consumption, maybe it's 100 watts, but 100 watts for 90 minutes in comparison to 2000 watts for 10 seconds. I think, yeah, you add some energy consumption, but you have to think about what you remove from the process. And I think if you make the calculation at the end, if you take a look, I think in battery line, you have a presentation about this specific topic. And the Faraday Institution in the UK in 2021 made a test to be able to reproduce in industry. And I think you gain 1,000 times you put originally. So 1,000 times in raw material, 1,000 times in electricity consumption, 1,000 times in your time. Every point of your process will gain. There is some disadvantages. Yeah, you make filtration, you need noise protection, you need maybe to have some place to be able to make the process, but most of the time you replace an existing process and it's only gain. There is no other things to think about it.
I guess we don't have any more questions, and we have come to the end of the webinar. So thank you very much, Alexander, for that insightful presentation
You're welcome.
on
I thank you.
battery recycling with ultrasonic solutions. Before we end the webinar, I would like to mention that batteryline.com will be present at the battery show in Detroit from 8th to 10th of October at booth 4800. Be sure to visit us and gain knowledge about how our members or partners enable gigafactories to scale up, just like how Mecasonic does. Uh, so thank you very much for joining us live today to the open talk session. If you have any questions, feel free to ask Alexandre directly, or you can also contact us at info@batteryline.com. So we look forward to seeing you at the battery show. Thank you.